Assalamu Alaikum. Hello guys. How are you? I hope that you all are fine. Today I will show you how to design a single reinforced section when a given factored moment for a given factored moment. Okay. Actually, we design this kinds of problem by using these two equations. Okay, this is very known equation to us, but we have to find out the actual value of a. We have to give a several trial. Okay, as at first we have to assume the value of a, then put it in the expression of as, then we get a value of as, then again we put it in the value in the expression of a, by several times to by giving trial and error we find out the exact value. Okay, that's a tedious process and time consuming. So stop trial and error and save your time. In this tutorial, I will show you how to obtain the the value of dimensions directly, and thereby find out the exact value of as. Okay, this is a problem of category 1. Actually, it's a continuous course of designing a beam, and I I have chosen the category 1 at first, which states that the design of concrete dimension and river area to resist a given factor moment. When a factor moment will be given, we have to find out the dimension, concrete dimension, and thereby the required river area. Okay, so let's get started. In this tutorial, we are going to follow a special technique. So why we shall follow this technique? We shall follow this technique for the following reasons. Number one, avoid trial and error, that is time consuming. Number two, exactly determine the effective depth and width. Number three, have a economical section. Number four, design in the quickest method. So let's solve a problem, and by solving this problem we shall practice that process. Okay, I will design the whole beam in a few steps. uh, if you follow these steps accordingly, I'm sure you will have no problem further about designing a single reinforced beam. Of course, it's under reinforced section. Okay, so let us start. The problem states that find out concrete cross section and the river area to resist a factored moment of 1670 kip-in material strength. F prime is equals to 4 ksi and Fy equals to 60 ksi. Solution: we are given that Mu equals to 1222 kip-in, F prime is equals to 4 ksi, Fy equal to 60 ksi, and let's assume that B equal to 10". Okay, the breadth of the beam uh, equal to 10". Okay, number one, step one, we have to find out the value of beta 1. This is the expression of beta 1. Okay, there is a limit of beta 1. The value of beta 1 lies in between 0.65 and 0.85. Okay, since here the value of a prime equals to 4 ksi, so we have to put the value of a prime in psi unit. So after putting the value of a prime c, we get beta 1 equal to 0.85. Step number 2, we have to find out the maximum depth of the compression block. Okay, maximum possible depth of the compression block, which is given by this expression. You should remember it, we should memorize it. Okay, it is going to come to work very efficiently. We have the value of beta 1 and fy and es. Put the values of beta 1, fy and es, and solving it, you will get max equal to 493 d by 1560. Let's denote this by equation 1. Step number 3, you have to find out the required depth of the compression block to resist the given moment. Okay, this is the expression of a required okay, which is given by d minus root over d square minus 2 mu divided by 0.765 a prime c. You should memorize it to have a trial and error method. Okay, after putting the values of mu, a prime c and b, we get the expression of a required. Okay, let's denote this by equation number 2. Since a max and a required, they are equal, there is no difference between these two expressions, so we can write a max equal to a required. From that, a max minus a required equal to 0. Okay, now put the value of a max and a required, so we get a function of d. Okay, if you solve it by calculator, you will get d equals to 14.32 inch, which is the exact value. Okay, which is the exact value. So we have found out the value of b and d, because b equals to 10 inch and d equal to 14.32 inch. But since the provided area of rebar is always greater than required as, so let's increase the value of d. Okay, let's increase it by 1 inch. If we add 1 inch to 14.32 inch, we will get 15.32 inch. Let's round this let's round this to the next integer value, that is 15.5 inch. Okay, thus we have found the dimensions of the concrete section, that is b equal to 10 inch and d equal 15.5 inch. So it's very simple. We have completed the first step, that is the concrete section, the size of concrete section. Okay, now we have to find out the required steel area to resist the given moment. Before doing that, let us calculate the minimum rebar area for the section size given, for the section size designed. Now we know that S minimum is given by 3 root over a prime c bwd by fy and 200 bwd divided by fy. The greater value, the higher value will control. So by putting the values of bw, the effective depth, and a prime c and fy, we get two values of S minimum, that is 0.49 inch square and 0.5 inch square, 51 inch square. The greater value will control. Okay, now let's design the required rebar area, which you can find by directly using this formula. Okay, you don't have to see the hither and thither, just use this formula. Okay, it's the under reinforced this is an equation for under reinforced section, so you don't have to think much. Okay, S record is given by mu divided by 0.45 fy times d plus root over d square minus 2 mu divided by 0.765 a prime cb. Okay, you have to memorize this formula. you have all the values. Okay, the value of D, the value of mu, the value of B, just the value of prime C. Just put all these values. Okay, by putting all these values and solving it by calculator, we get S required equals to 2.29 inches square. Okay, now if we use number 8 bars, then the number of bars will be 2.29 divided by 0.79. You know that the area of a single bar of a number 8 bar is 0.79. So divide 2.29 by 0.79. Okay, you get 2.289, which is near equal to 3. So provide 3 number 8 bars. As I said before that the provided area is always greater than the required area. Okay, that's why we used a increased value of D. Let's check out the clear distance between the two bars. Okay, so to calculate these, let us deduct the values of two two legs of the width of two legs of a strap. That is, if we use number 3 strap, then 2 times into 3 by 8. Okay, we know that number 1, the width of number 1 equal to 1 by 8 inch. So number 3 divided by 8, which is the width of the strap of one leg. So since there is a two leg of a strap, so 2 times 3 by 8 and 3 bars. Okay, 3 bars, you know that the diameter of a number 8 bar equal to 1 inch. So 3 into number 1, 3 into 1 inch, and the clear distance of two sides. Okay, clear cover of two sides, you know that for beam the clear cover is 1.5 inch for each side. So there is two clear cover, so 2 times 1.5 inch. So now since there is a two span between uh, two clear distance between the bars, num one is this and then another one is this. Okay, so two spacing, two clear spacing. So you have to divide this value by 2, which is equal to 1.625 inch, uh, which is greater than 1 inch. We know that the minimum clear spacing between two bars must be at least 1 inch. Okay, so it is greater than 1 inch, so it's okay. Hence provide 3 number 8 bars in one layer. Okay, so the design of flexural steel is completed. Now let's check the value of A max and A provided. Okay, you have to check out the capacity, and you have to check whether the beam is under enforced or not. We can check it by comparing the value of A provided with the value of A max. A provided is given by ASFY 0.85 A prime C, A prime CB. Okay, AS equal to provided AS. Okay, that is 3 times 0.79. You know that we have used 3 number 8 bars, so the provided area equals to 3 times 0.79 times the value of Fy equals to 60, and A prime C equal to 4 and B equal to 10 inch. By putting all these values, we get provided area, provided depth of compression block equal to 4.18 inch, and the maximum possible depth of compression block we have calculated before, that 493 D divided by 1560. So the put the value of D, we have provided 15.5 inch of effective depth, so we get 4.90 inch. Okay, the maximum depth of compression block equal to 4.90 inch. So our provided depth of compression block is less than um, maximum depth of compression block, so our beam is under enforced. Now let us check the capacity. which is given by mu equal to 0.90 ASFY d minus a provided divided by 2. Put all the values. Okay, we get 1760 kip inch, 16 kip inch, which is greater than uh, the given factor moment, which is 1670 kip inch. So our design is okay, no problem. Now the last step is the detailing. Okay, detailing of the flexural steel as shown below. Okay, the width of 10 inch and the effective depth equal to 15.5 inch, and the total height of the beam will be, you know, from this point to this point distance will be added to the effective depth. You know the diameter of number 8 bar equal to 0.5 inch, and the diameter of number 3 bar equal to 0.375 inch, and clear cover equal to 1.5 inch. At all these values you will get 2.375 inch. Okay, that is the detailing of the beam. I hope that you have understood how to design the flexural steel and the concrete dimension of a rectangular singly reinforced beam. Okay, of course it's a unreinforced beam. You know that we must design a section as under reinforced as a under reinforced section, because in under reinforced section the failure of the section, the ultimate the failure of the beam occurs when the ultimate flexural capacity is reached by yielding of steel first before crushing of concrete, which ensures the ductility of the section. Okay, if your beam becomes over reinforced, in over reinforced beam section, the failure of the beam occurs by crushing of the concrete before yielding of the steel, which occurs suddenly, which is not um, which is not expected. uh, I hope that you have understood and your concept is clear now why we should design a under reinforced section. Okay, thank you for watching. If you like my videos, please comment, like and share, and of course subscribe to my channel. It motivates me and helps and motivates me to bring more and more new videos for you. And of course tell me what you expect from me, and I will try to bring videos according to your expectation. Thank you. Assalamu Alaikum.